Well, welcome back everybody. We're going to be diving into this video and talking about how to configure some interfaces on the ASA. We're going to be taking a look at real quick high level of some of the different options that are available to you when it comes to interfaces. And so I'll do like a show interface and then the show command and stuff like that. It's going to be several individual videos instead of doing one long one that encompasses everything. So we'll start off with the physical interface. So we'll do where ASA v1 on gig 0/2 will be right here is we'll put that in like the connection going down to here, gig 0/0. I'll do like VLAN 10 here and VLAN 20 for the connection down to the server. And then, but the routers in the firewall will be on the main interface, which is VLAN 1. And then we'll do another video with .1Q7 interfaces and then redundant interfaces and stuff like that, and how that comes into play. And then take a look at same security level and intra-interface and inter-interface and things like that, just so we can cover all the bases. After we get done with that, all the setting up the interfaces options, then it'll be a dive in the next video, or I should say the next set of videos after we get done with interfaces is going to be setting up IP connectivity with like routing and stuff like that. So without any further ado, let's dive in. So go ahead and pull up Super Putty again. So on ASA v1, I'm going to go ahead and get the ball rolling here. I'm already in privilege mode. So we do a show interface IP brief. We have gig 0/0 is outside, gig 0/1 is outside. 2 and 3 are inside, so we're going to be focusing on those. So I'm going to type in no, and then type in interface gig 0/2. I'm going to type in IP address is going to be 172, or let's do 10. 10.100.1. or 10.1/24. I'll type in name if is going to be inside, and no shut the port. So now that I've done that, we do a show interface IP brief. The interface is up, it's got an IP address associated to it. Pretty simple stuff. So now that we have that, and the switch 1, currently everything's in VLAN 1, so there is no, I don't have to do any configuration to it. So what I'll do is I'll go over to test 9, and I will configure interface gig 0/0, IP address of 10.100.10.9/24, and I'll no shut that interface. Give that a second for it to come up. Boom. So now if I do ping 10.100.10.1 and give that a moment for ARP to resolve, and I get a ping reply. If I go over to ASA1 and I do a show ARP, guess who I can talk to? I can talk to test 9. And that's really the goal we're trying to accomplish here. So I'm going to go ahead and do the same thing for test 10 and 11 as well. So interface gig 0/0, IP address of 10.100.10. Sorry about that. .10/24. No shut that port. And do the same thing for 11. Interface gig 0/0, IP address of 10.100.10.11/24. And no shut that. Okay, with all of that done, now I have, now I can go back to ASA1 and I can say ping 10.100.10.10 and 11. Excellent. Show ARP. Everything's working as expected, which is awesome. So everything is doing what it should be doing. And it's just kind of ironic that the IP address correlates to a 9, 10, and 11. So A is 10, B is 11 in hex. So there we have it. So yeah, we're good to go there. So that is configuring the main interface for IP addressing. Now let's do some other stuff here. Let's do a show name if. And right now I have just the inside interface. So let's go ahead and type in interface gig0/3. We'll type in IP address of 172.16.100.1/24. Well, one too many D's. We'll type in name if is DMZ and no shut the port. So now show interface IP brief. Excellent. So now we're going to go pull up server 2. Server 2 is right here. And we're going to have to go onto here, go command prompt and type in ipconfig. Right now we're getting 172.16.100.1 and 10. Did I happen to just configure it the right way? I think I did. So let's ping 172.16.100.10. Let me see here real quick. Let me clear or ipconfig. Actually, I think it might actually be hard coded here. Yes. So close. Let me do. I have ipconfig /all. And my Mac is 22. Let's see why this isn't propagating. Let me come back over here and ping 172.16. Okay, that's working. Maybe it just took a minute for it to. My IP address is .10, right? Yes, it is .10. So why am I not getting a... Oh, okay, so this is not an issue with reachability because I can clearly ping the default gateway. Let me show you how to resolve this problem. So this is actually a problem with the firewall. So go to Windows Firewall. I don't know why it does this, but it does this. Let me go ahead and fix this real quick. Inbound rules. And we're going to go ahead and create one. We're going to say new rule. And I'm going to say that it's going to be a custom rule. Next. All programs. We're going to, from the drop down box, we're going to say ICMP version 4. And click next all the way through. And we're going to type in ICMP_in and click on finish. So now that rule is there. So if I go back over to the ASA and I hit the up arrow, now the ping responds. So it's just weird. Windows PCs and Windows servers, for some reason inside of Eve, you need to allow ping to come through. But that works. So now that we have that squared away, now if I wanted to communicate between test9 and that route. So right now on these routers, show IP route. Let me go ahead and do this. Type in no IP routing. So I want them to be in just an endpoint. So show IP route, just an endpoint. So let's actually do this. IP default gateway of 10.100.10.1. So now if I do a ping to 172.16.100.10, it's not going to work. Right? Now there's a reason why it's not working. And the reason why it's not working, if I was to debug, and this is, I'm a little bit in uncharted territory here. Debug, what's the one I'm looking for here? me see here real quick. I want to do a, is that a packet tracer? I don't think. Let me find it real quick. There is a inspection policy that, so if we were to do a show run policy map, down here, ICMP is not being permitted by default. So I'd actually have to, on this guy, let me go ahead and close out that, and close out this, pull up the server manager here. Let me do this real quick. Let me enable remote desktop just to prove that it's not something else. So remote desktop is currently disabled. Go ahead and enable it. Okay. And I'm going to disable allow connections that are less secure. Apply and OK. So I'm going to go ahead and, well, actually remote desktop is a bad example, but I should be able to, on test 9 now, I should be able to telnet to 172.16.100.10 on port 3389. And it's open. If I come down here and I type in netstat-nao and I scroll up a little bit, you will see right here, we go ahead and mark this. See this mark? If you see this one right here that I'm highlighting, that is test 9 being able to open up a connection to server 2 on port 3389. Now if I go back to the ASA and I do a show connection long, you'll see in the table that there is a connection going from the inside interface to the DMZ, so from 10.100.10.9 to 172.16.100.10 on port 3389, and we can see the connection clear as a bell right there. So we know it's working. We know traffic is passing through the firewall. Now let's go ahead and fix the policy map thing. Show run policy map. I'm going to go and take this right here. I'm going to go to global config, right click and paste this in and type in ICMP. By default, that's not inspected. I'm going to go back to test 9, and I'm going to go ahead and Control-Shift-6, break out of that, and let's do Control-C, exit. I'm not sure how to Control-Shift-6, if we were to ping 172.16.100.10, we'd be able to ping it now. And if we look back at the connection table, all the way down, well, it might have to be open longer than that. Let's do the ping repeat 100. There's the ICMP ping going out. So the ICMP goes back and forth and it works. So if we were to, eventually this is going to time out. It's established. So I'd actually have to go on test 9. And it's going to go ahead and, unfortunately there's no way to quit, exit, Control-C. These characters are being sent, but there's a TCP connection open currently. So Control-Shift-6, X gets you to break out of that, and so on and so forth. So what I will do is actually not try to break that out, but I can actually do on the firewall, I can do a clear connections, clear con all, and then if I go back over to this guy and hit the up arrow, that connection is now broken. So it's no longer up and running. The connections were deleted. So I can break the connection if I want to. So that's an example of how this can come into play and stuff like that. So now that we have all of that taken care of, let's talk about something else that comes into play here. Let's actually minimize this guy. So communication between these interfaces is good to go. Now you might say, in order, we know this is all working appropriately because they are on switch 1. Where's switch 1? Switch 1 is there. We do a show MAC address table dynamic. We know that there's a bunch of MAC addresses being learned. So we know 22 and we know 9. So this is test 9 and this is server 2. From a MAC address perspective, it's all in the same VLAN. But we knew by looking at the firewall rules that the traffic was going through the ASA for ICMPs and for the TCP connection. Until we allowed that to go through, it wouldn't actually pass through. And they might say, well, how come? Well, because test 9 and server 2 are in two different VLAN, or I'm sorry, two different subnets. So if they were all in the same subnet, it wouldn't have mattered because they'd be able to go directly to each other. Because of the fact that they're in the same VLAN but two different subnets, their default gateway is pointing. So you bridge when you can, you route when you must. What that means is when you hit, this is basic CCNA route switch type stuff here. So I'm not telling anything anybody shouldn't already know if they're a CCNA route switch. If I go to do an ARP lookup and my ARP process goes out and says, okay, I want to be able to ping 172.16.100.10 from 10.1.100.10.9. So from test 9 to server 2. If I want to be able to communicate in the same VLAN, in the same subnet, I don't need to route towards it, right? It's a little bit confusing if you've never dealt with it, but because the fact that server 2 and test 9 are two different subnets, bridging will not work in this case, or switching in this case won't work. You have to route the traffic. That's why everything had to go through. I knew that would happen, so that's why I demonstrated it the way that I did. So in cases like that, that does happen. So what I'm going to go do now is I'm going to go put, I'm going to create, I'm going to go put on ASA 1, I'm going to go ahead and put, let's do a show name if. So right now, the DMZ has a security level of 0. Okay, so I'm going to go ahead and I'm going to go to interface gig0/3, and I'm going to do a security level of 100. So I'm going to put them in the same security level. Okay. Now, if I do a show run all pipe include same security, hit the enter key, nothing's going to pop up. Now, I have the option of allowing same security level. So show name if, just to prove that they're in the same security level. Let's go back to test 9 and try to ping that again. It's not allowed, right? If we go to ASA 1 and we do a show connection table, there's nothing here, right? Nothing at all. If I go back to test 9 and I try to do that ping, let's try to do a telnet this time. Let's telnet to 3389. It's trying, but it won't work. It's trying, connection long, nothing's there. And just to prove it on the server, nothing is connecting, right? It's trying. You don't see anything on this side, but it is trying. Because we know we have 3389 open right here. It's listening on this port, but nothing's happening. Now, to fix this is same security interface, okay? On this, I'm going to go to global config. I'm going to type in same security traffic permit interface. Okay, so that's traffic from gig02 to gig0/3. Okay, that's been enabled now. I go over to test 9, and I hit the up arrow, and I try to do the ping. Guess what's allowed to go through? I go to ASA 1. I hit the up arrow. Well, let me reinitialize it because it goes away really quick. I guess I'm not fast enough. So let's do the ping of repeat 1,000 times and go to ASA 1, hit the up arrow. There's the ICMP ping, right? So we'll go ahead and we know that's working now. Let's get Control-Shift-6 on that. Let's do the telnet now. The telnet connection now is open. I hit the up arrow. I go to this. I see the TCP connection going back and forth. I know that's working the way that it should be. I come over to the server. I hit the up arrow. And guess what's working now? The connection here is up and operational. 3389 is the source port, or the destination port coming to the server. And the source port is 59,305. It's an established connection. So we know that's working the way that it's supposed to. That same security inter-interface. And the design that I'm using, without it going into VLAN interfaces or anything else, I really can't show you any of that. We will be showing you that. I should say I will. I'll be showing you how that works inter-interface when you have VLAN interfaces and you're separating each node or what have you by different subnets or VLANs and stuff like that. We'll be taking a look at that in the next video. So that's what I wanted to show you in this video. Pretty straightforward stuff. It does work the way that it's supposed to and stuff like that. Until next time, guys, thanks so much for stopping by, and we'll catch you in the next one.